calculus. Section 3-4, 6 to 28. I think I forgot to put on the pacing guide. There's that one, number 18, just like we did X17. Sorry about that. If you did it, it's just one of those graphing utility things. We're not usually going to do those. All right, number 6. Let's go. Find f prime of x. I'm ready. So let's see. F prime of x is going to be derivative of the first times the second plus the first times the derivative of the second. And then I'm going to simplify that. Haha, just kidding. No, I'm not. You can if you want to. Try to get it to match. Oh, these aren't even odds. You don't even have something to match it up to. So I'm going to leave it like that. I'm just going to simplify this first. Make it more calculus friendly. All those negative and rational exponents. Who knew they were going to be so nice for us in calculus? So rewriting that first piece like that. Now my derivative is the derivative of the first times the second plus the first times the derivative of the second. Want to simplify that? Hey, if you're wondering to yourself, if you do things the other way, in other words, if you do the first times the derivative of the second, and then you do the derivative of the first times the second, that's fine, of course, because multiplication and addition are commutative. I think it's an interesting personality test. The procrastinators of the world like skip over the first one, they get to the second one like, oh, I guess I'll have to take the derivative now, or something like that. I think 10 is one of these ones where it's going to be a lot easier if we just kind of if we don't switch our brains off. It's easier to just do a quick difference of 2 squares, simplifying there. Whatever, you can do it the other way. See if it's the same as that. Number 12. Looks like I'm going to need some low-d high. So let's see, low, d high. If you saw that coming and you're like, oh, that's just a 0, then good for you. Minus high, d low. It's 1/2 x the negative 1/2. There, so this is gone because that's all just a 0, but that negative sign remains. And then on the bottom I have that. And hey, that's just the square root of x plus 2 squared. Whoops. Square root of x plus 2 squared is just x plus 4, right? So you could simplify to that. No, just kidding. That is what we call bad algebra. You can't do that. Exponents do not distribute. Why? Because math. Because if you try this with actual numbers and then distribute the exponent, you get something that's not true. You can't do it. So watch out for that. Let's see, more quotient rule. Got dy dx equal to low d high minus high, oops, it's supposed to be a 4, d low over low, low. Okay. We saw some problems yesterday, or whenever you did those, where we were actually interested in setting this equal to something. So, you know, in a case like that, I would simplify. But here, I just don't see the payoff. doing that. All right, this is going to be interesting. So here it looks like I have a product, but one of the things inside the product is itself a quotient. So let's see if we can manage this okay. So ignoring what's inside the parentheses, I can clearly see I've got a product here. So I'm going to do the derivative of the first, because I'm not a procrastinator, 14x to the 6 minus 2x times the second plus the first times the derivative of the second. And when I get to the derivative of the second, that's a quotient rule. So that's low d high, it's just 1, minus high d low, also just 1, all over low, low. And it looks like the x's cancel out and you get 2 over that on the top if you want. So there it is. Maybe you want, x7, or x17, just kidding, x18, x, there it is, number 20. Let's see, for A, I've got g of x is equal to 3x squared minus 5f of x. So the derivative of that is going to be 6x minus 5f prime of x. And we want to find g prime of 3. Sorry, just g prime of x. It's the rest of my mathematical sentence there. G prime of 3 is equal to 6 times 3 minus 5 times f prime of 3 is 4. And that looks like it's going to be a big old negative 2. That's 20A. 20B. I've got g of x is equal to this quotient, so g prime of x is going to be equal to low, which is f of x, d high, which is 2, minus high, d low, over low, low. You can't mix up what you can't like write g prime of x here and then start writing the 3's in here. You can't do that. That's like writing down something that is just a lie. It's not true. Either you have to do all x's, x here, and x's everywhere here, or put the 3 here and then put all the 3's in place of the x's. You cannot mix that unless you want to be a propagator of falsehoods and destroyer of everything that is beautiful in the world. If that's your game, then you go for it. So f of 3 is negative 2 times 2 minus 2x plus 1, that's 7. And then f prime of x, f prime of 3 is 4. And then f of x, f of 3 is negative 2 squared. All right, so let's see where we're at here. I got negative 6 minus 28, right? Oh, did I mess something up here? I have f of, that's supposed to be negative 2, not negative 3. Sorry about that. So it's negative 4 minus 28 is negative 32 over positive 4. That's negative 8. All right. We're cruising along here. We're getting good at calculus. 22. So I want to find capital F prime of pi. And got an A, B, C, D kind of situation. That's going to slow us down a little. So in A, looks like our derivative is just going to be 6f prime of x minus 5g prime of x. Do you notice that I'm not doing the product rule? When I have the derivative of like 6 times f of x, this is just a constant. When you have a constant times a function, you can just take the derivative of the function and leave the constant there. You can do the product rule if you want to, but the derivative of the first is 0. You get the same thing. But definitely we want to be in the habit of doing those comfortably without having to think about the product rule. And you have been. I mean, you know that if y is equal to 3x squared, then dy dx is equal to, what we're really doing, you know it's 6x, right? What we're really doing is saying, well, I know by the power rule the derivative of x squared is 2x, and then I'm just going to slap that 3 back on there. Right? So this is the same idea. All right, so if I plug in here pi, then 6 times f prime of pi is -1, minus 5 times g prime of pi is 2. -6, no, that's -16, it looks like. B. Let's see, I've got x times that quantity. So this is a product, so the derivative of the first is just that x there, is 1 times the second plus the first times the derivative of the second. You could have distributed the x before you took the derivative and done it that way. I don't think it's necessarily much better or worse than doing it this way in terms of like how complicated it is. I think it's just about the same amount of work. So I'm going to plug pi in. So f of pi is 10 plus g of pi is -3 and plus x is pi. F prime of pi is -1 and g prime of pi is 2. So it looks like I have 7 plus pi. C. 2 f of x g of x. Okay, so in this kind of situation, let me write this out. I'm going to think of this as 2, a constant, times f of x times g of x. You can do it that way, or you can think of it as 2f of x, where that's your first, times g of x, and that's your second. Just assign the 2 to one of them, and then do the product rule from there. So you can do it either way. I'll do it both ways, so just to show you that you get the same thing. So if you're going to just move the constant to the outside, then you've got 2 times, because it's just a constant, product rule on this. That's that. And if you do it this way, the derivative of the first times the second plus the first times the derivative of the second. And you can see that that's exactly the same thing. So, I don't know. Again, doesn't really make any difference which way you do it, whatever you're more comfortable with. Now I'm plugging in pi. So I've got, I'll go ahead and use this one, I guess. So f prime of pi is -1 times g of pi is 2. No, that's g prime of pi. G of pi is -3 plus f of pi is 10 and g prime is 2. So let's see, that's 3 plus 20 is 23 times 2 is 46. How'd we do? Good. So last one, I have f of x over 4 plus g of x. Just some basic quotient rule. So low d high minus high d low over low, low. All right, so let's plug the pi in. So 4 plus g of pi is -3. So 4 plus -3, that's going to be a 1 there. F prime of pi is, I think I'd remember what they were by now, is -1 minus f of pi is 10, and g prime of pi is 2. And for g of pi is -3. 4 plus -3, that's 1 squared. So -2 looks like -22. No, sorry, that's -1, -21. 1 times 1 is 1. That says -21. Promise. And, all right, here we go into the fun ones. So I want to find all the x values where the tangent lines to this are horizontal. So that means horizontal tangent line means slope of 0. So let's see, low d high minus high d low all over low low. Not that the low is going to matter, because if you want your slope to equal 0 and it's a fraction, then the top's got to be 0. So let's see. I've got here on the top 2x squared minus x squared minus 2x and minus 1 equals 0. Looks like. I think that's good. A little bit of inspection here. That's not going to factor. So better quadratic formula it. Opposite of b plus or minus the square root of b squared minus 4ac. Huh? Oh, minus 4ac, so that's, no, yes. Minus 4ac, so that turns into plus. There we go. All over 2a. So simplifying that, it's going to be 1 plus or minus the square root of 3. Well, square root of 2. Just kidding. The 3. Because, no, that should be the square root of, what did I do wrong? I messed something up. B squared. B squared. How did I get 8 there? What the heck? That's 4. So that's an 8 under there, so that's 2 square root of 2, and the 2's cancel out. So yeah, it's that. Sorry. Whew. All right. Now I've got this y is equal to x plus 3 over x plus 2, and I want it to be perpendicular to, remember that symbol from geometry, perpendicular to the line y equals x. So in other words, it has to have a slope of 1. So find the derivative, set it equal to 1. So let's see. dy dx is equal to low, d high is 1, minus high, d low is 1 over low low. So I need to set that equal to 1. X minus x, those cancel. 2 minus 3 is -1 over x plus 2 squared is equal to perpendicular to this. This has a slope of 1, so to perpendicularize something, you have to turn it over, which is still 1, and make it negative. So -1. All right. Depending on how you think about things like this, I would see this I'm like, okay, negative 1 on this side and negative 1. There's already a negative 1 here. So if this is still going to be negative 1 on this side, equal to that, this has to be equal to 1. You can cross multiply and do algebra, whatever. And for this to be equal to 1, then the thing that you're going to square and get 1 is either got to be equal to 1 or negative 1. Well, there you go. Of course, you can just do some algebra, find those yourself, but I like to think sometimes and try to do it that way. Okay, the algebra, if you want to see it, looks like you would multiply, like you could think about it as like cross-multiplying, like this, but the negatives cancel out, so going to get x squared plus 4x plus 4 equals 1. Then subtract that over, so x squared plus 4x plus 3 equals 0. And then we factor it, and then you get your answers. All right, settle down. So one more, 28. This is a tricky one, kind of like 27 was from the last assignment. So 28, let me do it in the back of this. We have y equals 2x plus 5 over x plus 2. And this time we want the tangent line to have a y-intercept of 2. I'm going to make my little graph again. So whatever this function looks like, I want the tangent line to it to go through, to have a y-intercept of 2. In other words, it goes through the point 0, 2. So if this is that sort of generic point on here, x, comma, 2x plus 5 over x plus 2, then I need the slope of this line, which connects these 2 points, and therefore is y minus y over x minus x. So the slope is that, but of course the slope also has to be equal to whatever the derivative is, because that's what a derivative is. So that's low d high minus high d low all over low, low. So I do need the whole top here, and maybe, I think, well, actually, I think it's going to work okay if I don't simplify. Let's go ahead and simplify the top of this, then we'll set it up and cross multiply. So I've got 2x here minus 2x here. I've got 2 here minus 5. Okay, I think I did that carefully. And what I was looking at there, trying to decide how much simplifying to do, I was looking at this cross-multiplying up to this. That's going to knock out that denominator, so that's going to work okay for us. So crossing this up to here, I get minus 2x minus 2x. What the heck? Minus x squared minus 3x. And then multiplying this x plus 2 squared up to here. When it hits this term, one of the x plus 2's will cancel, and I'll get x plus 2 times 2x plus 5, minus, when it hits this, well, that's just 2 times that. All right, so let's see where we're ending up at here. Minus x squared minus 3x, foiling this out, 2x squared plus 5 plus 4 plus 9x plus 10, and then minus 2 times x squared plus 4x plus 4. All right, it's like the never-ending algebra problem. But that's okay, because we're good at algebra. So let's see if I can distribute and simplify here. 2x squared minus 2x squared. Those cancel. 9x minus 8x. 10 minus 8. All right, would like for everything to be on one side. I'm going to move this over here so I can have a positive leading term. X squared, let's see, plus 3x, that's plus 4x plus 2. And I happen to know that that has no solutions in the real numbers. So that's kind of a, after all that work. But looking at what's, oh no, that's not true. Hold on. No, that's if this number is bigger than 4. Sorry, that's a total lie. There's solutions. And the book is, I think I might have messed something up because the book has has nice answers, and mine are not going to be nice because that doesn't factor. So let's back up a wee second here and see where our mistake was. Our mistake. Look at that. I'm dragging you into the blame here. It was my mistake. Okay. Yeah, I know. That was not cool. So x plus 2. Just checking the right derivative here. Low d high, that's good. Minus high d low, that's good. Over low low, that's all good. So check my simplifying. Oh, wait a minute. I think I might see. Let's see. 2x minus 2x. 2x minus 2x. So I don't know how I have something here. That doesn't belong there. And then I have 4 minus 5. Jeez. Messed them both up. 4 minus 5. How did we do that? Just kidding, it was me. Alright, is that the only mistake? I think so, because this was just the slope formula. So, then this whole side here is just minus x. And if that's right, then that's minus x minus 2x equals 2, so x equals negative 1. Is that it? That's the only, yeah, I guess that's it. So that's the x value. Sorry about all that mess there. You were probably jumping up and down in your chair when I messed that up right there, weren't you? But we caught it. We caught it.